Welcome to Draw and Design. In this video we are going to use Naviate Rebar extension in Revit to install the reinforcement in a beam. So here we have a beam. We have a full frame model of a building. So this one is a beam which we are going to use in Naviate REX to install reinforcements. If you haven't already, please subscribe to my channel and click on bell icon for future updates. Without any further delay, let's get started. So click on this beam and now click on Naviate REX tab. In this area you can see we can install the reinforcement in lots of structures. So in this video we are only going to cover the beam section. Now click on this beam section. Naviate will open up this tab for you. So in this area, first of all, you can see the geometry of our beam. So we have a rectangular beam with 1.25 feet into 2 feet dimensions, and Naviate also automatically detects this beam section. The dimensions and the columns and beam dimensions are all automatically detected. So we are going to start with stirrups. Click on this stirrup. So we have two types of stirrups. We have normal stirrups and we have anti-shrinkage reinforcement. So if your beam is also supporting the anti-shrinkage, so click on this one, and then you can set the main bars, skin reinforcement, and the stirrups or ties in the beam. So we are not going to use anti-shrinkage reinforcement in our video. So we will uncheck this one and start with this one. So we are going to use number 3 dia bar. Then we are going to use the simple stirrup type, and for the hooks we are going to use 135 degree reinforcement. So for the cover, you can also set the cover in the main reinforcement settings. Next we are going to click on Stirrups Distribution. So in here you can detect or you can manually select the spans. Also you can select from here, and you can also select from this preview image. So one by one we are going to set the reinforcements. For the span number 1 we are going to use distribution type as like this one, and for the dimensions, these are lots of dimensions which are shown in these images. So for DL we are going to use 2 inches gap from the first stirrup, and for the center to center spacing we are going to use 4 inches, and also 4 inches on other side. For L1 and L3 we are going to use this one 17 feet and 3 inches clear span length, and we are going to distribute this one on L by 3. So this will be approximately 5 feet and 4 or 3 inches. So we are going to write manually 5 feet 3 inches, and also here 5 feet 3 inches. After that we are going to set the DR, right side distance of first stirrup. So we are also going to use 2 inches. As you can see this preview image here, this is very clear demonstration. So for the next one we are going to select the span number 2. Also you can manually click on this one. For span number 2 we are also going to use same specifications. So this time 5 feet 7 inches, 5 feet 7 inches, 4 inch center to center spacing, and the middle area 9 inch spacing, and the end area also 4 inches spacing, with DL 2 inches and DR 2 inches. After that we are going to select the span number 3. So span number 3 in our beam is a cantilever portion, so we are just going to use the normal distribution type with 3 inches center to center distance. And for DL we are going to use 3 inches, 1.5 inches. So this one will be our setting for stirrups. Next we are going to click on bars main. This one will set the main top and bottom bars. So bottom bars are shown in this area and top bars are shown in this area. Later on these rebars can be distributed as per the splice length or maximum length of rebar. So we will cover that one in the bar division area. So for the time we are going to use number 6 rebar and number 6 rebar on both bottom and top reinforcements. Next we are going to use 4 bars in bottom and 2 bars on top. LA and LB are shown in this diagram. We can manually set this one to 1 feet and 3 inches, 1 feet and 3 inches, both side 1 feet and 3 inches, like this one. This bottom and top bars, for now we have set 4 bars and 2 bars. Later on we will cover the splice lengths in bar division. For the time we are going to install the additional top bars. So for the additional top bars, our top bars, extra bars should be placed on sports area. So for the first one we are going to use this one as first span number 1. So we are going to install this rebar with LA 1 feet and 3 inches, and our L length, this length of this bar shall be up to L by 3. So we are going to place it on 5 feet. Next we are going to install the bar above the right support. So check this one also, and our bar is shown in this area in the red color. So for this one we are also going to use number 6 bar and number 6 bar, but this time number of bars shall be 2 extra bars on edge support and 2 extra bars on middle support. For the dimension of this bar, LR and LL. LL means length of left side and LR means length of right side. So we are going to use 5 feet 3 inches and 5 feet 4 inches, like this one. These hooks which you are seeing in this area, these are the additional hooks on the end of this rebar, end of this LA side. So these are the additional hooks. We do not need to install these hooks for now, but if your beam is designed for these hooks, you can also install these hooks 90 degree and 180 degree. So let's move on span number 2. We are going to use number 6 bar, 2 bars, 5 feet, this left side support. For the right side support we are also going to use number 6 bar, 2 bars extra bars, and for this one we are going to use 5 feet 4 inches. And the other side, for the other side we are not going to use this one. So let's uncheck this one and move to span number 3, and for this one we are going to use this rebar, because the cantilever sides, the top extra reinforcement shall be continued to the other side of beam, other side of the support up to L/3. So for this one, number 6, 2 bars, let's make this one 3 bars, and for this one L, this means the length of this bar. Length of this bar shall be 9 feet 10 and a half inches plus 2 feet 6 inches and plus 5 feet 4 inches. So this one will be 17 feet and 4 inches, like this one. So this one is shown up to here, but color is only mentioned on span number 2. If you move to span number 2, this one is shown in here also. So this one length is correct, but the LB means the end hook, this one we will make 1 feet 3 inches. Now the additional top bars are installed. Now move on to additional bottom bars. So for the bottom bars we are going to select span number 1, and for the bottom bars, first of all we are going to use end edge support. So for the edge support, this L length shall be up to the distance, height of beam distance, after height of beam distance, which means 2 feet from the column, this bar shall go up to 2 feet from the column. So we are going to use number 6 bar, and this dimension is 12 feet 11 inches. So we are going to use, let's check, 14 feet. So this is 2 feet and 11 inches. Let's check 15 feet and 2 inches, 4 inches. Let's make it 2 inches. So this is exactly 2 feet, which is the height of our beam. 2h shall be the distance between the edge of support and this bar. So for LA we are going to use 1 feet 3 inches. Now let's move to span number 2. For the span number 2 we are going to use span bar, this span bar. So we are going to use number 6, 3 bars, and we are going to install this bar same as the previous, 2 feet from both sides. So this one will be, this is 17 feet 6 inches. This means that 2 feet from here and 2 feet from there, which is 4 feet, and remaining is 13 feet 6 inches. So which will be 6 feet and 9 inches, and this one will also be 6 feet 9 inches. So we have 1 feet and 11 and a half inch on both sides, which means 2 feet. Next we are going to move to span number 3. So for the span number 3 we do not need the bottom bars, because this is the cantilever portion and we have already installed the top bars up to the previous L/3 area. Let's move to bar division area. This one need to be understood carefully. First check this one, division of main top bars. So we have maximum length of bar is 40 feet. This one depends on your project, but the coefficient shall be 60 die of bar, which means the splice length shall be 60 die of main bar. So which will be in the number 6 bar case 3 feet and 9 inches. So this distribution is automatically made by Revit extension. we do not need to change this one. Also check the division of main bottom bars. This one shall be 60 die-off bar, so this is it. Now if you want to check the reinforcement areas, you can insert the required reinforcement as per the standards. So we do not cover this one in this video. This is just an introductory video. We will make a detailed video on the beam reinforcement in the coming sessions. Now all the settings are made, so we just click on OK. Revit will automatically generate the reinforcement in this beam as per our setting. Now the reinforcements are made, but we cannot see in this realistic view. We have to switch to wireframe. In the wireframe view you can see the reinforcements. If you want to view these reinforcements clearly, just filter out the reinforcements, structural rebars, and then go to view visibility state and click on these shall be checked in 3D views, and click on OK. Now click on realistic view and click on fine. As you can see, the reinforcements are clearly placed and there is no error in this. Our all reinforcements are placed, bottom reinforcements, also the cantilever side, extra reinforcement, these reinforcements, these. After Naviate install or generate the automatic reinforcements, you can also change manually these reinforcements can be changed manually. For example, if you want to change these reinforcements to die-off bar, so you can just directly click on these dias and this one will be changed. So this one was the introductory video which we recorded for Naviate. We will cover the details in the next video. I hope you like this video. If you like this video, subscribe to my channel and click on bell icon. And that's it for this video. See you in the next one.